This is C4, section 11, integration by inspection, on page 37 of the C4 booklet. So, as usual, if you want to take notes, you'll need to pause and take notes. Unlike a normal lesson, I won't be pausing to give you a chance to write up. So, every time you learn to differentiate something, you also learn how to integrate something. So a to the ax plus b to the power of n, when you differentiate, you multiply by the power, you multiply by the number in front of the x, and you take 1 off the power. When you're integrating, you do the opposite. So you add 1 to the power, you divide by the new power, and you divide by the number in front of the x. So you get ax plus b to the power of n plus 1 over a times n plus 1 plus c. When differentiating e to the ax plus b, you take the a to the front, so you get ae to the ax plus b. So you times by the a. So when you're integrating, you do the opposite, the inverse, you divide by a. So we get 1 over a, e to the ax plus b plus c. Now for this one, the integral of 1 over ax plus b dx, if you're differentiating ln x, you get 1 over x. So let's try differentiating, set aside, y equals ln of ax plus b. By the chain rule, you would times by the a, so divide by the x equals a over ax plus b. So integrating the other way around, if we've got 1 instead, we must have started by 1 over a ln of ax plus b. But that one we're going to do more things with in later sections to probably make it a bit easier than thinking it in the way we just covered it there. Now sine, cos differentiates to minus sine, and the a would go to the front, so we're going to have to divide by a instead of times by a. We have to deal with the minus, so the minus is there. We get cos of ax plus b plus c. Sine differentiates to cos. If we had ax plus b, the a would times at the front, so we're going to divide by the a. We get sine ax plus b plus c. And sec squared, well, tan differentiates to sec squared. If it was tan of ax plus b, we'd times by a at the front. So we need to divide by a and turn it back to tan. So that's really very quickly in terms of explanation for the formulae. You may want to practice the differentiations yourself and work backwards to get a better feel for it. But when it comes down to it, these are the formulas you need to remember and be able to do. Either in formula form like this, or in a process form like it's e to the ax plus b, I need to divide by the number in front of the x. Whichever way you learn how to do it, you need to be able to do it. One other technique, of course, is like we did there, is where we take a guess and differentiate it, and then we multiply and divide by constants to make the original the correct answer to the integral. Now, the formula booklet is also very useful in terms of giving you integrals that you don't need to remember the answers to. So, the integral of tan x dx in the formula booklet is ln of sec x. Formula booklet doesn't put in the plus c's, but obviously that would count as well. Cot x is ln of sin x. We put modular signs around these functions because you can't do ln of a negative value. But it is a bit more complicated than that, but at the level we're working at, we just need to just take that as correct. The integral of cosec x gives you two different options. So these two are relatively common. These two are not so common. So you've got minus ln of cosec x plus cot x plus c, or over half x plus c. And sec x, again there's two possibilities, ln of sec x plus tan x plus c, or ln of tan a half x plus pi over 4. So they're in the formula booklet in the C4 section, you don't need to remember them, but if you see these functions to integrate, look them up. Also in the C3 section we have various differentiations, derivatives, that we can reverse to find their integrals. So sec x differentiates to sec x tan x. So if we're integrating sec x tan x, it integrates to sec x plus c. Cot x differentiates to minus cosec squared x. So cosec squared integrates to minus cot x plus c. And cosec x differentiates to minus cosec x cot x from the formula booklet, and therefore cosec x cot x integrates to minus cosec x plus c. So again, you don't need to remember these, but you do need to remember the relationship. So that you can look up in the C3 section, reversing back to that for the C4 usage. So there are two ways to deal with it. You learn the formulas and you can process them, or you can make a best guess, differentiate, and then adjust your guess to make it correct. So for cos 2x plus 3, a sensible guess would be y equals sine 2x plus 3. Differentiating that, 2 goes to the front, sine turns to cos. That's why we chose sine, because we know that sine differentiates to cos. Now that's 2 times too big, so our original guess was 2 times too big. Or it's just a simple case of applying that formula from a couple of pages ago. Again, e to the 4x plus 1, well e to the power usually integrates to itself, e to the x. So I guess, in our guess column, I'm making guesses, y equals e to the 4x plus 1. If we differentiated to y by the x equals 4e to the 4x plus 1. So that's 4 times too big. So when we integrate, we divide by 4. Plus c. Again, looking here, we know that tan differentiates to sec squared, so a good guess would be y equals tan of 3x. Differentiating to y dx equals 3 sec squared 3x. So it's 3 times too big, because we only want 1. So the answer is a third of what we started with. Again, we could just apply the formulae for any of these, but some people prefer the guessing method. So part D, 1 over 3x plus 2, we could have guessed y equals ln of 3x plus 2. Differentiating, we get 3 over 3x plus 2, which is 3 times too big. So it must be a third of my original guess. Or apply the formula. So for E, We know that differentiating takes the power down, so our guess would be 2x plus 3 to the power of 5. Differentiating, the 5 goes to the front, the 2 goes to the front. We take 1 off the power, so we get 10 times 2x plus 3 to the 4. So it's 10 times too big, so our answer is 1/10 of our guess. For sine, cos differentiates to minus sine. Won't worry about the negatives because that's a constant. When we guess, we can just deal with adjusting the answer of differentiating our guess. So differentiate y equals cos 3x minus 3. We get to y dx. 3 goes to the front, cos turns to minus sine. So we get to y dx equals minus 3 sine 3x minus 3. So we wanted 6, we've got minus 3. So we need it to be minus 2 times as big. So minus 2 times cos of 3x minus 3 plus c. Again, the formulae would still work for these. And finally, 2 sec 4x tan 4x from the c3. No, sec x differentiates to tan x. So our guess would be y equals sec 4x. Differentiating, the 4 would go to the front. So we get 4 sec 4x tan 4x. So that's 2 times too big, so we need it to be halved. So I halve our guess. Half sec 4x plus c. So 2 possible methods. Memorise the formulae and just apply them. Or best guess, just our answer on differentiation. Need to be able to apply definite integration. If it's trig functions, it will be in radians, just like when differentiation, trig has to be in radians. When it's integration, trig has to be in radians. So our guess would be y equals sine 4x minus 2, because sine differentiates to cos, differentiates to y dx equals, the 4 goes to the front, 4 cos 4x minus 2. Well, we want 5 and not 4. So we need to divide our guess by 4 and times it by 5 to change it from 4 to 5. So 4 divided by 4 times 5 will give us back to 5. So 5/4 of our sine 4x minus 2 guess. Then as usual, we put the top limit in first, take away, put the bottom limit in. In some cases you'll be expected to do exact answers, but you won't be able to in this case. So we'll be expecting a calculator generated rounded answer. So sticking it in just now, sine 4 I over 6 minus 2 for the end. It's 3 significant figures, 0.901. But beware, many questions will give exact answers where the numbers are nicer. Final example. We've got 2 functions, so we can do the guesses separately for them. So for the first one, it's ln. For the second one, we need a power that's 1 higher. differentiate. So we would get 4 over 4x minus 1. So our answer is 4 times too big. No, 4 today. Our answer to the differentiation is 4 times too big, so we need to go a quarter of the original. Four minus x to the power of 3. We take the power to the front, number in front of x, which is minus 1, so minus 3. Take 1 off the power. Now we're supposed to have plus 1, not minus 3, so we need to times our original guess by minus a third. And then again, plug the numbers in and simplify. Now this is one we could do exactly, so we will. So quarter ln 4 times 5 minus 1 minus a third, 4 minus 5 cubed. Doesn't mean you can't use the calculator for various bits of it, of course. A quarter ln 4 times 2 minus 1 minus a third, 4 minus 2 cubed. So we've got a quarter ln, 4 times 5 is 20, minus 1 is 19. Minus 4 minus 5 is minus 1, minus 1 cubed is minus 1, sines minus a third, plus a third. Or just use your calculator. Minus a quarter ln, 4 times 2 is 8, minus 1 is 7. 4 minus 2 is 2, 2 cubed is 8. It's minus 8 over 3, don't forget the brackets around the last two terms. Collect the terms together, so it's a quarter ln 19 minus a quarter ln 7 plus an 8 plus a third minus minus so plus 8 over 3. Third plus 8 over 3 is 9 over 3, which is 3. Quarter ln 19 minus quarter ln 7. So quarter, factorise the quarter out. Then laws of logarithms, we can bind them to one log, ln of 19 over 7. So an exact answer for this would be a quarter ln 19 over 7 plus 3. And that concludes this section.